Hi everyone. In this video we're going to talk about solving trigonometric equations. And so what that means is equations that have trig functions in them. So when you're going to solve a trigonometric equation, what's going to come up is an inverse trig function. And so the two that we're focusing on in this class are arcsine and arctangent. So the trigonometric equations we're going to focus on are the ones that have sine and tangent in them. So here's an example. Say I have square root of 2 times sine theta minus 1 equals 0. Right, so here is an equation that has a trig function in it. And what I would like to do is find all the values of theta that if I were to plug it in to this equation, it would give me an output of 0. That's my goal. Find every single possible value of theta that if I were to plug it in on the left-hand side, this would end up being 0. Okay. So with any trig equation, what I like to do first is rearrange everything so that I have just the trig function by itself. Right, so that's the thing that's most helpful to me. So what I'm going to do first is I'm going to add 1 over to the other side, and I'll end up with the square root of 2 times sine of theta is equal to 1. And then I'm going to divide both sides by the square root of 2. So this gives me sine of theta is equal to 1 divided by the square root of 2. Okay. So 1 over the square root of 2. This is a strange way of looking at this, but it could come up. So typically what we see with trig functions is the value of the square root of 2 divided by 2. But 1 divided by the square root of 2 is really the same thing in disguise. So if I were to just convert this and multiply top and bottom by square root of 2, you would see that this is the same thing as the square root of 2 over 2. Okay. So I need to know what values do I plug in for theta, what values do I plug into the sine function to give me an output of the square root of 2 over 2. Right, and so we know that an answer to that question is this here. It's theta equals arcsine of the square root of 2 over 2. Okay. So if you were to plug this into your calculator, arcsine of the square root of 2 over 2, or if you look it up, right, so you can use your first quadrant trig values, you would get an answer of pi over 4. But the problem with this is this isn't the only answer to my equation. Right, so I can use the inverse trig function to give me one solution, but I know that there are more out there. Okay, so arcsine of square root of 2 over 2, this is one possible solution. But let's try to find the others. Right, so I often like to go back to the unit circle and think about it this way. Okay. So pi over 4 is over here. So if I plug this in, I'm going to get a y-coordinate of the square root of 2 over 2. And I know that sine is also positive over here in quadrant 2. Right? And so if I went straight across, right? So if I went straight across from pi over 4, I would get another point over here on the unit circle. That would be another solution. So I need to think about what is this value over here in quadrant 2. All right, so this is where our reference angles are very helpful. So I know that this distance right here is pi over 4, and it's going to be the same as this distance here along the unit circle. So to figure out what that is, I know that this is pi, right? So pi is over here, and I want to go back by pi over 4, so I get pi minus pi over 4 is equal to 3 pi over 4. And so this value right here is 3 pi over 4. Okay, so two solutions that I have right now. I have pi over 4 is one of my solutions to this equation, And 3 pi over 4 is also another solution to this equation. So I have two solutions right now. So I want you to think for a second, are there any more solutions to this equation? Okay, so pause the video, take a moment, think about it. All right. So hopefully you came to the conclusion that yes, there are more solutions, because if I were to start here at pi over 4, right, I know that pi over 4 is a solution, but if I added 2 pi to that, I would go all the way around the circle and end up in the same spot. So if I went one full rotation by 2 pi, if I added 2 pi to this, I still have a solution. And if I did it again, I would also have a solution. And if I did it again, I would also have a solution. So I have to take into account all possible rotations around the circle, and I have to do that for 3 pi over 4 as well. So the way that we do that is we say that we have solutions of a particular form. Right? So the solutions to this have the form, okay, solutions have the form pi over 4 plus any possible rotation around the circle by 2 pi. Now, I can do that once, I can do that twice, I can do that any number of times. So I'm going to put a k here and say that means I can do this any number of times. And it turns out I can do that for 3 pi over 4 as well, plus 2 pi times k. And the caveat here is that k has to be an integer. Okay, so k is going to be 1 for one rotation around, or 2, or 3, or 4, or 5. And the negatives are also in there too, because we could rotate in the other direction. Okay, so here is one trigonometric equation, and all possible solutions have the form pi over 4 plus 2 pi k, or 3 pi over 4 plus 2 pi k for integers k. All right, so I hope this helps. I'll see you next time.